So welcome everybody. I'm Bob Miller. I'm president of Marin Conservation League. I'm also chair of the Marin Conservation League's Climate Action Working Group. Marin Conservation League develops and advocates for environmental positions that meet our mission, which is to preserve, protect, and enhance the natural assets of Marin in a changing environment. This committee focuses on mitigating climate change. Other Marin Conservation League committees focus on a wide range of environmental issues: parks and open space, land use, transportation and water, agricultural land use. And those issues include adapting to climate change. Now, for those of you who are members, a big thank you. We need your support to continue to do our advocacy work. And for those who are not members yet, you can join at marinconservationleague.org. So I'm going to put the agenda up for the meeting. What we're going to do is have an initial session on carbon removal from the atmosphere and its storage. Then that will be followed by a Marin BioMass project report, a report on recent EV infrastructure developments, and reports from organizations. So,
Got my name wrong.
sorry? Okay, so I'm going to stop sharing. And if you can just give me a moment. Here we go. So sorry for that delay. This topic of carbon removal from the atmosphere and its storage has been around for decades. And actually just a few decades, but it's been around for a while. But a couple of recent developments have forced us to pay attention to the issue. Several highly respected reports from international organizations have said that we cannot meet climate change targets without carbon removal and storage. And closer to home, the California Air Resources Board issued its 2022 climate change scoping report, and every 5-year report, and is projecting a huge increase in carbon removal and storage. So California currently emits around 400 million metric tons of CO2 equivalent each year. Carb seas removal about 25 million metric tons by 2030, and 100 million metric tons by 2045, which is a huge amount relative to emissions. So our speakers are going to focus on carbon removal from the atmosphere, focusing on using natural solutions and engineered solutions. We're not going to hear much about carbon removal from concentrated CO2 emission sources like power plants, refineries, cement, and steel mills. Our first speaker, Sarah Baker, is a material scientist at Lawrence Livermore National Lab. She's the lead author of a 2020 Lawrence Livermore National Lab report, Getting to Neutral: Options for Negative Emissions in California, Carbon Emissions in California, which has been an influential report. She's working on a similar project for the Department of Energy, looking at carbon removal options for the entire United States. She'll provide an overview of methods of carbon removal from the atmosphere and define terms. Then she'll focus on engineered solutions, especially waste biomass related solutions. Then Jeff Creque from Carbon Cycle Institute will discuss natural solutions to carbon removal and sequestration. He's been a real leader on this in this area and elsewhere in California. So a couple of housekeeping things. First, please keep yourself on mute. Second, put your questions in chat so the speakers can see what questions are coming. And third, we're going to put a video of the main presentations on YouTube shortly after this meeting, a couple of days after this meeting. The speakers have agreed to that, and participants should keep that in mind as well. With that, I'm going to turn it over to Sarah Baker. Sarah?
Hi, thank you. Let me share my screen here. Nice to see so many people interested in this topic. And I look forward to hearing Jeff's presentation as well. So I'm going to talk about our findings regarding carbon removal in California. And just a little bit of background where this, how we got involved in this topic at Livermore. Several years ago, Roger Ains started what's called the Carbon Initiative at Livermore. And I don't need to go into this much, but I think we're about 100 people strong at this point. And we're working on everything from analyzing how to approach carbon removal to working on technological solutions, assessing soil carbon, and identifying geologic storage projects. Speaking with everyone here today, I'm really looking to understand what questions and issues people have with these sets of solutions I'm going to talk about. And as Bob said, we've been working on these types of analysis for about five or so years now. I'm starting with this Getting to Neutral report. This was a major team effort funded by ClimateWorks and the Livermore Lab Foundation, about 20 authors, not just nationwide, but we also had some others from outside the country. And then we followed that up with a report for Microsoft, looking at the most near-term solutions that a corporate buyer might invest in to reach net neutrality for a company like Microsoft. And finally, as Bob mentioned, we are working on an analysis for the whole country. What are the regional solutions, negative emission solutions for the United States? And we are looking to release that at the end of the summer. So it's going to be a busy summer. Okay, a little bit of background that was already touched on a bit. Our report was really looking at this green wedge here. So if we look at this plot, these are California emissions and a timeline. And prior to Governor Brown's executive order to get to net zero by 2045, the California's plans for emissions reductions are shown in the yellow line here. These were two Senate and Assembly bills, followed by, at the end here, this Governor Schwarzenegger's executive order. So these are all emissions reductions. And you can see that if we want to actually get to net zero, this curve takes on an entirely new slope. That's because it's very, very hard to scrub those residual emissions, about 100 million tons, from the economy. And so to counteract those, we need to actually remove carbon dioxide from the air. Our report was focused on about 125 million tons. You know, this isn't an exact number, but it's actually consistent with other assessments of what we will need. What are these residual emissions? You know, everything from heavy duty transport to agricultural emissions. Very, very challenging to remove from the economy. So our report was the first comprehensive assessment of available negative emission solutions for California. And when I say comprehensive, we looked at everything from how do you remove the carbon dioxide from the atmosphere to where does it go and everything in between, and also how much does it cost. And so we looked at three major types of pathways that are tailored for California. So we didn't look at industries that don't exist in California today or offshore sets of solutions. Everything that could occur within the state. And this is summarizing these three main categories: natural ecosystems, so storing carbon in plants and soils. The second one here is biomass conversion with carbon removal. I might call it actually in this presentation as shorthand bikers. So biomass for carbon removal and storage. And I'll talk more about that. But basically you take biomass, you treat it to convert it into fuels, electricity, chemicals. Necessarily carbon dioxide is emitted from this processing, and you capture it and you put it underground in permanent storage. The third option is direct air capture. I'll talk more in depth about this as well. This is using purpose-built machines to capture carbon dioxide directly from the air and store it safely underground. So you can see 2 out of the 3 of these categories require geologic storage. And here's really, this is the sort of bottom line up front from the report. We did look at cost, and because we're looking at cost, we only looked at technologies where we could assess the cost. So these are all what we call technological readiness, mid to high. No breakthroughs required, no miracles required. The good news is here that we did find that solutions exist today, if scaled up and implemented, that could get us to 125 million tons per year removed by 2045 to get us to neutral. And this shown here is the combination of solutions that when combined get us to the lowest cost, about $8 to $10 billion per year. And so this requires maximizing our natural solutions at 25 million tons. The highest impact we saw was actually this biomass conversion, because this can remove the most carbon dioxide at an intermediate cost, and then we round it out with direct air capture. Now, one thing I want to point out is that we need all 3. We can't actually get to 125 with just one of these. That was another major finding. So we have work to do. As I mentioned, this was comprehensive, so we also included costs and emissions from carbon dioxide and biomass transportation, as well as a cost for geologic storage within California. And finally, where does the carbon dioxide go? Around 100 million tons per year would need to go underground in geologic storage reservoirs. And it turns out California has fantastic geologic storage resources, some of the best in the United States. The carbon dioxide goes underground where oil was previously extracted in general. And when injected deep underground, it actually assumes the same properties as oil. So it turns into a liquid. I often get questions about this. I am not a geologist, but I've been told by many geologists this is very very, very well understood. When done right, it's, you know, we can just assume the CO2 is underground permanently. Carbon dioxide storage underground has been going on, I believe, for about 40, 50 years. Globally, around 50 million tons have been stored underground, mostly for enhanced oil recovery. We did identify specific locations that are especially promising for geologic storage, shown in these 2 boxes here. And we found that there is about, you know, several hundred years of storage available at the injection rates that we would need in 2045. So this is what we call a cost curve or a supply curve for CO2. And I'm going to be referring back to this. So I haven't really talked about costs yet. And I'm actually trying to move, I'm trying to move the pictures around so I can see it. Okay, so on our y-axis here, we have a negative emission cost, and on the x-axis, we have amount of CO2. And again, this is our lowest cost set of solutions that I showed earlier, where we have natural solutions coming in at the lowest cost. That's the way we really want to maximize it. And I'm sure we'll hear later, there are so many other benefits to employing these natural solutions, and they're available likely much sooner. And then in the middle here, at intermediate cost, about $30 to $100 per ton, we have our biomass for carbon removal and storage and various pathways here. And I will talk a little bit more about that. And then up here at around $200 per ton, we have direct air capture, which we included technological learning. We put it on a learning curve and assumed a certain amount was deployed to get it down to this cost. We do need to keep deploying direct air capture so that we can learn how to make it cheaper. All right, so again, I'm not going to focus in on these natural solutions. I think we're going to hear more about them later, so that's fantastic. I'm going to talk about the bikers and the direct air capture, and just talk a little bit more about specifically, you know, what these are, what they do, and a little bit of, in the case of bikers, the relevance in California. So again, bikers, biomass carbon removal and storage really shifts a paradigm about how we value biomass. Previously, biomass was really regarded as important for energy to displace fossil fuels, and of course it is. But we are also looking at it for its value in carbon removal. In fact, for our national report, we're looking at some purpose-grown crops, and we're calling them carbon crops, not bioenergy crops. In California, biomass is actually more valuable for its carbon than its energy. Okay, so what is this bikers pathway here? Again, plants and trees, they are fantastically evolved to use solar energy to capture and store carbon dioxide and energy. They do that for us for free. And then if we take the waste biomass, and I just want to emphasize, we only looked at biomass that's already produced in California, and that if we did nothing with it, that carbon dioxide would be re-emitted to the atmosphere in the form, you know, through oftentimes wildfires, as we're very familiar, or decomposition, where it actually can turn into methane, which is far worse than carbon dioxide. So let's put it to work. And that we use various conversion processes, which I can talk about. You can make products, fuels, chemicals, materials that displace these chemicals and fuels that are currently using fossil carbon. And then you also take the carbon dioxide coming off the process and put it underground. For California, again, we only looked at waste biomass. Every county in California has waste biomass. It's kind of fascinating to see how different it is across the state. Everything from gaseous waste, which comes from biogas, municipal solid waste down here in the south, forest management waste, so forest thinning as prescribed by forest services to reduce wildfire risk up here in the north, and then Central Valley, we have agricultural residue. So what's happening to a lot of this today, it gets flared in the case of gaseous waste. It decomposes to methane that might leak. In the case of municipal solid waste, it gets burned in piles and impacting air quality in the Central Valley and in the north. So this is about, in total, 56 million bone dry tons. If we converted all of that to carbon dioxide, it would yield about 100 million tons of CO2. So this is a really busy plot, we call it, or a figure, we call it a spaghetti diagram. Now what we do with this biomass to convert it is dependent on the characteristics of the biomass. Broadly, a lot of it just has to do with how much water it has. I'm going to be talking about a few of these technologies, just a little bit more in depth to explain them. But we have the type of biomass here, and then we have the technologies here that are all ready to be deployed, but will take some scaling insights and know-how. So gasification, combustion, pyrolysis, hydrothermal liquefaction, and biogas utilization. And then up here we have the types of products that we looked at: hydrogen, grid electricity, liquid fuels, biochar, and renewable natural gas. If there are any questions so far, I actually can't see them, so just interrupt me. So the first, and also please let me know if I'm going over time here. The first type of bikers I wanted to just highlight here is this one, this bar, biogas to electricity with carbon capture. And the reason I wanted to highlight that is because it's extremely simple and avoids emissions from methane. So we take manure or landfill gas or biogas from wastewater treatment. This is already produced. It makes biogas when these wastes are fermented anaerobically without oxygen. All you have to do to make negative emission renewable natural gas or methane that can displace fossil methane in the grid is separate out the carbon dioxide and put it underground. And this is an example of anaerobic digestion of manure. And so, this has a number of benefits. You don't emit methane from manure decomposition. You capture it and use it, and then you also are able to harvest that carbon dioxide and put it out of the atmosphere permanently. This is a picture of a flare at our local wastewater treatment plant in Livermore. The challenges with biogas utilization is that a lot of the sources of biogas are really small, so it's not economical to do anything with it. So oftentimes it's flared to avoid emitting methane. But this is a wasted resource. So one thing that we're working on here at Livermore is technologies for efficient, low cost separation of CO2 and methane at small scale. And this is something that's we should really be doing. There isn't actually enough biogas in the state to get us all of the negative emissions we need, though. So just quickly looking at low moisture biomass that allow us to use something that we broadly can categorize as thermochemical conversion processes. So low moisture wastes are forest residues, agricultural residues, currently either in the Central Valley pile burned and forest fires and pile burned in the Northern California as well. So these thermochemical processes account for the majority of the removal from bikers at very comparably reasonable costs. And a lot of these pathways make hydrogen. That's because you can get as much CO2 out of the biomass as possible if you make hydrogen, because there's no carbon in the product. So this is an overview of these types of processes. The biomass goes through a thermochemical conversion process to make electricity, hydrogen, liquid fuels, biochar. The list goes on. We're even, for our national report, looking at making asphalt. I won't go into this process flow diagram for gasification of biomass to hydrogen, but when one does make hydrogen, you retain 50% of the biomass energy in the hydrogen, and 99% of the carbon can go underground. So it's a great use of biomass carbon. And then it would displace how hydrogen is made today, which is emits a lot of fossil CO2 in its production. And there are gasification to hydrogen companies starting in the state. One example is Moat Hydrogen. The challenge here is that they require large scales for economies of scale. It's kind of challenging to start these big projects. And I wanted to highlight an example of a type of facility or of an exemplary facility that we might emulate someday in California. So this is a facility in Sweden that currently uses biomass to make heat that heats essentially the whole city. And they're looking to put carbon capture on it. And when they do, it'll capture about 1 million tons of CO2 a year. And this is an exemplary facility because it's in the middle of the city, it's clean, it's right next to a school. Anyway, it was Roger Ains, the head of our carbon initiative, went and visited and was very, very impressed with how these facilities can be designed. All right, do I have time to talk a little bit about direct air capture, or should we?
Sure, a few minutes. Yeah, great.
Okay, so direct air capture, this is the most expensive type of technology here for carbon removal, but it does not require any biomass. It does require renewable energy. So it's over here, highest cost. Need to deploy a lot to buy down the cost. I do want to mention direct air capture is carbon capture, but carbon capture, as usually described, is referring to capturing carbon that came from underground. So post-combustion capture. So carbon capture is usually, or CCS is usually actually preventing emissions from fossil sources. You can follow this arrow. Carbon comes from underground, goes back underground. What we're talking about here is carbon dioxide that comes from the air and goes underground. This is direct air capture. It's so simple conceptually. Essentially, the carbon dioxide comes from the air, binds to a filter. CO2-free air comes out the other end, and then you regenerate the filter and capture the carbon dioxide. Here's the challenge. Trying to capture that amount of CO2 out of the air is like shaking hands with about 40 people in this stadium. You gotta push a lot of air to find the carbon dioxide to capture. it makes a lot more sense not to emit it in the first place. However, we know it's going to be needed. Requires a lot of energy. So about 250 megawatt for every million tons. For that reason, it requires renewable energy to actually emit net negative CO2, if that makes sense. If you have a dirty grid and you're running on grid electricity, it'll actually emit more CO2 than it pulls out. So some big projects here, Climeworks, Global Thermostat in the United States. These are using these solid sorbents. I believe this is the largest project in the world, Climeworks Orca facility in Iceland. And this is working well in Iceland because they have geothermal resources and geologic storage. So that's I know I kind of breezed through the end there, but that's the end of my talk here. I just wanted to summarize what is needed. We'll need infrastructure in California to get to neutral. We'll need to start moving carbon dioxide and putting it underground, and very helpful to start deploying direct air capture to bring those costs down as soon as possible. But so many benefits: wildfire prevention, air quality improvement, jobs, and most importantly, showing the world that if California, with an economy as large and diverse as ours is, can get to carbon neutral, that the world can too. And that's it. Thank you.
Terrific. Thank you so much, Sarah, and thank you so much for all the work that goes that's behind all of these slides. You know that the reports are quite something to put together. Okay, so we'll have an opportunity to discuss this, but first what we're going to do is go to Jeff Creque from the Carbon Cycle Institute, who's going to talk about carbon removal using natural solutions. And Jeff, you've been a real force for this in this area and California-wide, so good for you. So why don't you take it away, Jeff?
Okay. Are you able to see my screen?
Part of your, yes.
Let's see here.
There you go. Perfect.
Okay, great. And thanks, Sarah. That was spectacular overview of that work. So I'm going to, as Bob said, talk a little bit about natural solutions to removing CO2 from the atmosphere. My friend John Wick, founder of the Marin Carbon Project, has defined agriculture as the art of moving carbon among carbon pools to produce the products of agriculture. I think it's an apt definition, and it, I think, points to how agriculture can be a climate solution. Just a few interesting points, as Sarah's pointed out, we're not going to stop global warming without removing large quantities of CO2 from the atmosphere over a sustained period of time. Agriculture has played a pretty significant role in bringing about the climate crisis. Upwards of 1,000 teragrams or 1 billion metric tons of carbon has left the US soils and moved to the atmosphere over the last couple of hundred years. At the same time, agriculture, of course, is extremely vulnerable to climate change. Farmers for generations have depended on knowing when the first frost is coming and the last frost is happening, when the rains are going to come. None of that is actually predictable at this point, and it will become less predictable as we go forward. But the exciting thing for agriculture is that soil carbon really, I think, holds the key to achieving negative emissions at the scale and in the time frame that we actually need to. This is from work of the UN Convention to Combat Desertification, suggesting that soils can hold upwards of the equivalent of about 1,100 tons of carbon dioxide per hectare. A hectare is about 2.5 acres. There are roughly 2 billion hectares of degraded land globally, which is an area larger than South America. And restoring those soils has the potential to store up to 3 billion tons of carbon annually, which is about a third of the annual carbon dioxide emissions currently. So this is where we are. We're, as of a couple of days ago, we're sitting at 421 parts per million of CO2 in the atmosphere. What's interesting to note, and this is work by Sanderman and others back in 2017, that as human beings have engaged more and more of the planet's surface in agricultural enterprises, particularly grazing and cropland management or mismanagement, if you will, we have seen an increasing emission of CO2 from our soils, from loss of soil organic matter and its conversion to carbon dioxide through oxidation. So agriculture and land management in general has played a very significant role in driving this upward curve of carbon dioxide in the atmosphere. And there's a very important opposite side, if you will, or alternative side to this dilemma that we're facing. And I think it's often ignored or simply not understood, that because photosynthesis is fundamentally, as Sarah pointed out, the transformation of solar radiation into biochemical energy. The Earth, as framed by Shramsky and others in 2015, in a really seminal paper, the Earth can be seen as a biochemical battery, if you will. And through 3.5 billion years of photosynthetic capture of solar radiation, the biosphere has been charged, if you will, as a biochemical battery. 2,000 years ago, given the human population of that time, we had about 70,000 years of phytomass available to feed the global human population. And today we're looking at less than 1,000 years of phytomass remaining on the planet. The Food and Agricultural Organization of the United Nations in 2015 suggested we have 60 harvests left. 60 harvests, and that was 7-8 years ago now. So this situation is sort of the counterpoint, if you will, to our excess CO2 in the atmosphere, and we need to take this very, very seriously. So this is just a very small offering of what we've done to the living planet and how we continue to radically reduce its capacity to utilize solar radiation to draw CO2 from the atmosphere. And as we degrade our biosphere, we obviously reduce our capacity to utilize that carbon dioxide in the creation of the various material goods that we rely on as a civilization. So this brings us to carbon farming, which is the idea of engaging agriculture as a climate solution by beneficially transferring atmospheric carbon to our working land soils and vegetation. And this is just an example of a project in Marin County on a Chileno Valley ranch, showing a restoration of a riparian system over about a 20-year period. And you can imagine how much carbon has been absorbed within this restored riparian system. You don't just have to imagine it, however, because David Lewis and his team have done an excellent job of actually quantifying the benefits and showing that within the channel, the floodplain, and the upper bank, we have significant increases in carbon content in both vegetation and soils over time as these systems are restored. In this case, over about a 20-year period, we're looking at about 1 million tons of carbon dioxide equivalent, which we can transfer into, say, the energy usage of 6,000 homes over a 20-year period. I'm not sure if my screen is blocking those figures.
Yeah, you're good.
Okay, great. This is work done by the National Academy of Sciences, trying to sort of demonstrating that as we invest more dollars into this work, we can obviously achieve greater benefits. And so at $100 a ton, we're looking at, according to this analysis, upwards of somewhere in the order of 800 million metric tons of benefit from the natural systems, forest management, afforestation, agriculture. So clearly, dollars have a lot to do with what kind of work gets done and how much work gets done. Similar analysis done by Adam Chambers with the USDA Natural Resources Conservation Service back in 2016, taking the French proposal 4 per thousand initiative that came out of the Conference of Parties in Paris in 2015, suggesting that if we could increase soil carbon globally by 0.4% on an annual basis, we could completely offset all of our industrial emissions globally. This is showing a trajectory to get to 800 million metric tons of sequestered carbon by 2025. Of course, this is now a paper from 2016, and very little action has actually been taken in this direction. But hypothetically, again, engaging that 4 per thousand concept at scale across the United States, 800 million metric tons over about a 10-year period. Clearly, soils have a really important role to play here. There's 2 to 3 times more carbon in the soils and in the atmosphere. It's suggested by the National Academy of Science, again, that we could be storing about 1.4 billion metric tons in global agricultural soils alone, and looking just at the topsoil. And this is based on the 4 per thousand initiative concept. And that about 80% of this potential could be reached at a price of about $100 a ton, which they suggest is a price compatible with the 1.5 degree centigrade target. Unfortunately, the California Air Resources Board and their recent scoping plan, I think, falls flat with respect to natural working lands. I won't read through this whole thing, but there's a grotesque underestimation of the potential of natural working lands, and particularly soils. The modeling conducted by ARB is by their own admission inadequate with respect to soil potential. But their conclusion is that total carbon stock change from 2014 to 2045 will be negative 4%. In other words, we'll see a net loss of carbon from our natural working lands over the next 20 years. That's simply unacceptable. I don't think we can accept that as a conclusion. And if this is really where we're going, we're in real trouble. Just one example of one of the, I think, erroneous assumptions in their analysis. They note that they want to increase climate smart agricultural practices by at least 78,000 acres annually. The NRCS in California today is already treating over 80,000 acres annually with climate smart practices. So I think the CARB analysis, as I said, is really hopelessly inadequate with respect to natural working lands. But hopefully the new expert advisory committee that was just formed and looks to be a pretty outstanding group of folks will help the Air Resources Board come to more of an ecosystemic perspective on California's climate dynamics. Frankly, I think this is where we're headed in California. Obviously, this is a photo from the 1935 Dust Bowl, but all you have to do is drive down through the Central Valley in the summer these days, and you can see very similar situations. We've taken 500,000 acres of land out of production due to soil degradation, salinization, and drought in California, and more to come. If we look at organic matter across California's soils, it's a pretty bleak picture in our agricultural lands. NRCS has suggested that a 5% organic matter content is an indicator of a healthy soil. You can see from this image that very few of our agricultural regions have 5% or anything close to it. Most of our Central Valley ag lands are sitting at about 1% organic matter, which is a reflection of a history of extractive agricultural practice, but it also opens up the possibility of enormous carbon storage potential within those working land soils. This is just a simple analysis we did with respect to increasing soil organic matter using compost. So taking that biomass that the Getting to Neutral report suggests we should be converting to energy and pumping underground for permanent storage. Instead, we'll move that biomass into soil fertility, converting it to compost and applying it to working land soils. At a rate of 3 tons of compost per acre, which is virtually nothing, we would be sequestering about 27 million metric tons of CO2 annually across the 10 million acres of irrigated working lands in California. And these values don't include avoided methane emissions or nitrous oxide emissions from reduced fertilizer use, nor does it include increased photosynthetic capture of carbon dioxide, or the Air Resources Board's own compost emission reduction factor, which is about 0.5 ton of CO2 per ton of organic feedstock. So lots and lots of potential within our working land soils in California, which has been sadly unrecognized. This is from work of the Marin Carbon Project, in showing us that not only do we gain the benefits of adding carbon to our soils directly through the addition of compost, but we also can initiate a positive feedback process within the working land ecosystem by enhancing the capacity of plants to grow, and in other words, to photosynthetically capture carbon from the atmosphere. A single application of compost in this model scenario, using data from the Marin Carbon Project, shows that a single application of compost can lead to annual increases in photosynthetic capture over the ensuing decades, as many as 30 or 40 years of enhanced carbon capture due to enhanced photosynthetic growth from a single application. And even 100 years out, we still have more carbon in that ecosystem than we started with. So very significant potential if we think about the dynamics of living systems. The SB 1383 is requiring the diversion of organics from landfill and its utilization as compost and mulch across jurisdictions in California. This is Marin County showing the requirement to use 20,000 tons of compost annually through 2026. That's about 40,000 yards of compost. Some folks wonder where we're going to put all that compost, and the reality is that we would have no problem utilizing that compost on Marin's agricultural and working lands. We have about 60,000 acres of grazed grassland in Marin County. We could absorb about 100,000 cubic yards of compost annually, and it would take us 20 years or so to get all of that covered up. So we could then induce about a 1.5 tons increased photosynthetic capture annually through those compost applications, yielding about almost 90,000 tons of CO2 benefit on an annual basis. These changes in soil organic carbon content can happen very, very quickly. This is an example from a Mendocino Coast vegetable production operation. The upper left is the mineral soil at about 1.5% organic matter. And 4 years later, this producer had transformed her soils into about 6% organic matter using compost, using cover crops, and avoiding tillage. The unincorporated area climate action plan for Marin County suggests we need to reduce GHG emissions by about 168,000 metric tons by 2030. About half of that is anticipated to come from agriculture, and this is based on analysis done for the climate action plan by David Lewis, by the Marin Agricultural Land Trust, and Carbon Cycle Institute. So looking at existing carbon farm plans in Marin County, we have 20 operational plans right now, sequestering about 9,400 metric tons annually. We hope to have 60 plans done by 2030, sequestering about 65,000 metric tons. And by 2045, if we can achieve 180 plans and implement those plans, we could expect to be sequestering about 500 million metric tons of CO2. Important, again, I want to emphasize this relationship between the capture of solar energy through photosynthesis and the function and biodiversity of our working landscapes. The more solar energy we can transform into plant biomass and soil organic matter determines how resilient and how biodiverse our working land systems will be. Graphic example from another riparian restoration project in Marin County. This is on the Stemple Creek Ranch. You can see over time how much biomass is accumulating in this restored riparian system. What you don't see, but is represented in this quote from farmer Lauren Poncha, as this system has recovered, there's been an enormous increase in the diversity of migratory birds that nest within this habitat. So again, a direct relationship between the potential for the biosphere to capture solar energy and then support living systems with that captured bioenergy. Lots of co-benefits, of course, from increasing ecosystem carbon listed here. I won't read them all, but there are certainly many. And importantly, I think for California and really the entire Western United States is that the hydrological impact of the loss of soil organic carbon over the last 200 years is approximately equal to the hydrological impact of climate change itself. So as I noted earlier, we've lost significant amounts of soil organic carbon from our working land soils. And in this analysis by McDermott and others, they show a 30% reduction in soil organic carbon, which is the very low end of what we've actually lost. In some cases, up to 75% of our soil organic carbon is gone. But this loss results in soil moisture losses that are on par with the 2000 to 2020 dry climate anomalies in the American Southwest. So we really need to be thinking about carbon as a critical element in the functionality of our ecosystems. This similar work done by the USGS, Alan and Lori Flint, looking at the impacts of increasing working land carbon across California, 44 million acres or so of our working lands, by increasing carbon content by 1%, 2%, 3%. And you can see a net benefit across all the counties of the state, the counties across the bottom here. Obviously, high variability is a function of different soils across these counties, but showing a really significant benefit, about 6 million acre feet of benefit from increased soil moisture storage, increased evapotranspiration, which is to say, increased plant productivity, and increased groundwater recharge. Roughly 6 million acre feet of additional hydrologic benefit. The state's prepared to spend $5 billion to build a 1.5 million acre foot reservoir at the reservoir site. So you can see the value and the importance of addressing the gaps in our soil organic matter content across California. For Marin County, a 1% increase in soil organic carbon on all 160,000 acres of our rangelands would represent about 2.6 million metric tons of CO2 removed from the atmosphere, and would increase the soil water holding capacity by about 26,000 acre feet, which is more water than is held in the Casio Reservoir. Yeah, just to close, the good news is we can actually do this. First step, of course, is to immediately and dramatically reduce our emissions, and then to seriously invest in our soils and our working lands as beneficial sinks for atmospheric carbon. The bad news, of course, as we're all well aware, is that we've run out of time and we need to act now. I put this in because it's, I think, really important. This is placed at the former location of the Icelandic glacier, whose name I can't pronounce, but it says Oak is the first Icelandic glacier to lose its status as a glacier. In the next few hundred years, all our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done. Only you know if we did it.
Terrific. Thank you, Sarah. Thank you, Jeff. Two terrific presentations. We really do benefit from this. So I think what we'll do then is move to chat. There seem to be quite a few questions on biomass utilization. So Ken Strong asks, what are the California pilot projects for either biomass removal or direct air capture? I think you touched on one of those projects in your presentation. Do you know of others?
I know that geologic storage projects are getting going. I think since our report, there are about 6 or so. In terms of carbon removal and direct air capture, I know there is a bid for a direct air capture hub to get funding from the Department of Energy. And beyond that, I think there are lots of startups. One I can point to is Charm Industrial. It's in San Francisco. They're currently putting CO2 from waste biomass in Kansas underground as pyrolysis oil. But there are a lot of energy in our area. A lot of small companies starting up.
And there's a question from Kelly Jones. Does negative emission methane release any CO2 or leave methane residue during combustion when it's used?
Yeah, so if methane is combusted without carbon capture, the CO2 will be emitted. If the carbon in that methane came from what we call biogenic sources, so not fossil, that's a net neutral emission of CO2. In our analysis, we captured the CO2 at the biogas generating facility, and we captured the CO2 on the power plant. So there's no emissions of CO2. But that's kind of maybe unrealistic that both of those things would happen.
So a question from Bob Archer, which is perfect for a materials scientist to answer. What are the top materials research priorities for direct air capture?
Yeah, I actually borrowed some of these slides from our direct air capture expert, Simon Payne, in my group here. The major ones are contactor efficiency. So you have to move so much air. How do you minimize power loss from having to move all that air? Efficiency and regeneration of the sorbent material. How do you remove the CO2 from being bound to the filter in the most energy efficient way? Because the filter has to bind strongly enough to grab the CO2 in the first place. So there's kind of a push and pull there. In my group, some of our team is working on durability, science of durability of the capture media, capture materials. These materials need to last thousands of hours for the economics to work out. And we're trying to understand how to modify them to get them to last that long.
A question from, again, on biomass seems to be, it's something new for most folks, waste biomass utilization. Jack Leapster asked, how do the costs and emissions of collecting and transporting biomass fit into the calculation? So it's a transportation issue.
Or is this for me or Jeff? for me?
I think it's for both.
Okay.
I think it's can you say something about I believe it's, can you say something about the transportation costs and how important they are?
Sure, we did look at that. We found that for certain technologies, it makes a lot more sense to move the biomass. And some technologies, it might make more sense to move the carbon dioxide. And we looked at, the balance of those costs. But it doesn't make sense to do both. So you either locate a facility where the biomass is, convert it there and move the CO2 to where the storage is, or you locate the facility where the storage is. It would be very helpful to have a carbon dioxide pipeline. That's how you get the lowest cost carbon dioxide transport. But biomass by rail is actually, it's the most economical option for most of these things if you don't have a CO2 pipeline. Hopefully that answered the question partially.
Thank you. Jeff?
Yeah, I don't have too much to add to that other than trucking costs for biomass in the form of wood chips is about $10 a ton right now, and that's hauling from Marin County up to biomass plant in Woodland, and that's about the best information I've got on that topic.
Mm-hmm. So don't call it a question, and maybe I could duplex the question of my own. She said these technologies have been difficult to bring to scale. They're very expensive, and I guess she's talking about the engineered solution, so far not feasible or desirable when there are natural options. Can you talk some about what the barriers have been to achieving scale and what you know about the increase in subsidies for carbon removal and storage and its likely impact? Presumably it's having an impact on the number of startups. Can either of you say something about what the impact of the increase in subsidies has been or is likely to be in the next couple of years?
Go ahead, Jeff.
Well, very briefly, I can't speak too comprehensively to that, but USDA has just invested almost $3 billion in efforts to across the country to develop what they're calling climate smart commodities. In other words, looking for folks to develop systems that will result in carbon negative, if you will, agricultural systems for producing various agricultural commodities. So that's one example. California's Healthy Soils Program is another example. Some $75 million, I believe, this year going to support on-farm activities that will presumably result in net climate benefits. So those are just there's certainly more going on, but I think those are two of the big examples that I can think of.
Yeah, I know that LCFS in California is very helpful, and then the National 45Q is helpful as well. But I am not. I'm not aware of the actual economics of how these things play out.
Okay, and LCFS is low carbon fuel standard. Yeah. Okay, so Corey, you have if you're here with us, you have a long question. I'm wondering if you could pose it.
Sure, thanks so much. Jeff, I was really intrigued by your data on having plenty of space for carbon farming to use our SB 1383 requirements, but our requirements for procurement are annual. And what I understood from talking to folks was that the application on carbon farms is once every 5-10 years, something like that. And so I'm wondering, do we really have enough space? Like, it seemed to me that we were going to have a lot more to procure than we could utilize on farms in West Marin. Can you lend a little bit more insight into that?
Yeah, that there's a couple of things going on there, Corey. The Marin Carbon Project research showed a single application of compost to graze grassland, and subsequent research by Wendy Silver's group is showing that reapplication probably would need to happen about every 15 years or so. But there are working pasture lands in Marin County, as you know, receive annual applications of manure. They could better be receiving annual applications of compost. That would definitely improve the greenhouse gas signature of that activity. So there's a significant opportunity there. Our croplands can certainly use annual applications of compost. So and then of course our parklands and urban landscapes can absorb annual applications as well. So I think there's more than enough land area to absorb the relatively small amount of material that 1383 is calling for annually. Yeah.
I love how you call it a small amount. To us, we're like, but another quick question, if you don't mind with the follow-up. One of our concerns too is the water quality impacts of applying all this, especially when we're starting to see what, the amount of contamination that's in the compost that's currently being produced. Really, what are the concerns around that, and what are the implications around that, I guess?
Yeah, I think that the water quality impacts, I think, are fairly easily addressed. Nutrients in compost are relatively immobile. They're biologically bound within the compost material. That's not to say there aren't leachates that derive from compost, but observing appropriate riparian buffers and not over applying and utilizing compost appropriately is key to that. Contaminants, the contaminants we have to worry about in compost in California for the most part, given regulatory oversight, are physical contaminants, plastics, metals, things that not heavy metals, but actual physical pieces of metal, pieces of glass. Those are real issues, and to some extent they can be addressed through proper screening. But more importantly, I think we need to educate the public about what they put in their green can and what they don't put in their green can, and that's a challenge, and that's something that really needs to be addressed.
Okay, there's actually a related question from Jim Burrows, asking about carbon capture on working lands. That to be successful in the Central Valley, will that require additional irrigated water resources?
Good question. Yeah, I think to establish the agroforestry practices, for example, that the Healthy Soils Program is promoting, and that I think we could all agree would be a good idea, would take some additional water resources, definitely. Presumably, lands being some land on each farm taken out of production for agroforestry practice installation. There may be some available resources there. The question is, how do we invest some carbon to recapture the ability of our soils to absorb water? And if we may have to make an investment in order to build that water holding capacity. So I think it's a really important question. But if we don't begin to reinvest in our working landscapes, we're going to see this continuing downward spiral in both the quality and the land area that's available for farming in California.
Yeah. So there are a couple of questions in chat talking about the concerns, huge expense, and inefficiencies and dangers of tech-based carbon capture. Sarah, you're familiar with folks' concerns. How do you address those?
I guess I'd want to hear what the specific concerns are. Are we talking about carbon capture on a power plant or direct air capture from the air? You know, if we're concerned about air quality impacts or some sort of pollution, you know, we are looking at that for direct air capture. We don't see a path for any increased emissions of any type of pollutant, air pollutant. So I'd be curious to hear what the specific concerns are.
Yeah, Louise, you're here. You want to talk about the concerns and see whether those concerns, whether you're talking about the type of carbon capture that Sarah's been talking about.
Yes, thank you. And I'm really excited with the land-based projects because I think that's really a fabulous way to go. Food and Water Watch has put on several seminars recently talking about some of the research that has been done in this area and how even just increasing hydrogen, they're now finding that in itself increases the potential increase of other like methane and other gases that we certainly are concerned about. And they're talking about the various inefficiencies and the cost and the subsidy would be much better spent in other ways. And they're also talking about just having a pipeline with carbon apparently will have more potential leakage than we now see with oil. Apparently it turns into liquid and it could leak just as badly as or more. And potentially we will be increasing, according to their research, even more potential fossil fuels, and the emissions haven't been properly done, and the regulations on some of these. Apparently the EPA, they do not have the proper regulations or the money to enforce them, and there will be just giving money out without proper regulations to control what potentially could go forward. There's a lot of information they have, and I would be happy to even forward the recordings of the last couple ones that I have personally attended and was very impressed with the research they have done.
Thank you, Louise. So there's lots and lots to unpack there. Some of it some of which does not directly pertain to the research that you're doing, Sarah. Do you want to address any piece of that?
Yeah, I would say in general, I think everyone wants the same result, right? We all want a livable, safe climate. And the best science I know says that we need to reduce emissions as fast as we can. And we also need to start to remove carbon dioxide from the air, starting mid-century. So we're gonna, you know, I'm hearing a lot of distrust of technology. You know, I think there's a lot of concern that if we deploy carbon dioxide removal, that it's somehow going past to keep emitting, or that there are going to be unforeseen consequences of carbon removal technologies. We are looking into this very, very carefully. I don't see any red flags. We've been, again, putting CO2 underground for decades. We have CO2 pipelines in the US, thousands of miles. Today, they've been around for decades. So yes, we do need to be careful in how we proceed. And we do need to reduce emissions. And we also, according to, you know, IPCC and sort of the scientific consensus, we do need technological solutions for carbon removal to have a safe planet. It's unfortunate, but this is where we are. And I do believe we can do this in a way that is safe and actually is beneficial for people. So.
Great. Yeah. So we're going to have to come to an end to this this session. This is a question from Andrea Taylor. Can California achieve carbon neutrality soon with distribution of compost and compost tea applications on conventional soils that are effectively ruined? So this has to do with the timing. How quickly can this scale up? Jeff?
Yeah. Well, I think it goes back to Corey's question really about compost quality. There is no problem getting farmers to use compost. If the state were to distribute free compost, farmers would take it up. However, it has to be of a quality that they're comfortable with. And that is something that's a real challenge. It's a technological challenge fundamentally, because it's a question of how do we separate organics and non-organics in our waste stream. However, given and I think one of my slides showed this, given the state of California soils and the vast land area involved, there's enormous potential there. We're not going to achieve neutrality in California from compost alone. The biggest obstacle we face is stopping emissions. But there's no question that compost can play a major role, and not just compost, but carbon farming itself, which engages the capacity of the working lands to absorb CO2 through photosynthesis. So, compost is a very potent strategy. I don't want to give folks the impression that we're going to solve this problem with compost. But I do think we have to be thinking about utilizing our biomass resources to rebuild our ecosystems rather than seeing it as a waste product to be permanently pumped underground. On the other hand, I totally agree with Sarah that we need every solution available to us at this point. And barring my concern about removing CO2 from the biosphere, I think the work that the Lawrence Berkeley Lab and others are doing in this sector is critically important. But that said, I believe the potential for California's working lands to be a major player. The Climate Center estimated 100 million metric tons annually by 2030. That's a pretty high number. I think we could probably do half that, but that's a significant number. 50 million metric tons annually by 2030. Now maybe 2035 as each year passes and we do nothing. I think there's enormous potential, and we haven't even begun to explore that in California.
Great. I guess a last question that I have is for you, Sarah. For the important work that Lawrence Livermore National Lab is doing, you did that work for California. You're now doing something similar for the Department of Energy. Wondering if you could just outline what that's about, because that can have national impact.
Yeah, we are, it's sort of like the California report kind of helped us as a blueprint for the country. So we are looking at the same basic categories that I described. The interesting thing then becomes how regionally diverse the U.S. is. Looking at Alaska, Hawaii, corn stover comes into play all of a sudden, right? The Southeast forest. So there's just a lot more factors to consider. But what we're looking to put out, just as the California report was helpful for people because it's county by county. You can see what's in your county and what the solutions are available. It's going to be every county in the U.S. and grouped by regions so that we can, highlight regional opportunities and considerations for all of these types of solutions: forest, soil, bikers, and direct air capture.
Correct. Well, thank you to both of our speakers. We have a number of other questions, but I think we're going to have to draw this to a close. Thank you to both of you for your really wonderful presentations. Just very helpful. And I said that to I think it was Sarah, that when talking about the audience, that this is a vastly overeducated audience on average. I didn't know very much about this topic, so this is very helpful. Thank you.
Thank you.
Thank you very much.
Thank you.
Yeah. Okay, so before we get to the next item on the agenda, which is a report on the Marin biomass project, David Lewis, who is a board member of Marin Conservation League, wants to make an announcement about a policy statement on carbon sequestration that we're working on. David?
Sure, Bob. Thank you. And real pleasure to be with you today. Really appreciated both of those last presentations. And I'll be very brief, just as an announcement, a way for you all to know Marin Conservation League has a climate management policy statement, and has then taken the effort to make 3 more complementary statements. One has already been approved on sea level rise. 2 others are in the works: carbon sequestration and biodiversity. The draft carbon sequestration policy statement, with many of the board members here today helping contribute and helping review it, including Jeff Creque, and I think friends of Marin Conservation League like Bill Carney have given us input. I think I saw Nancy Hughes here helping us with urban forestry, for example. It largely focuses on those natural solutions, or what we've been calling nature-based solutions, and the ecosystems and working lands, and is reserving both the air capture technologies that Sarah Baker mentioned, reserving that for further work by COG before we begin to make policy statements around that. It also, though, does have a placeholder for biomass, and I'll be exploring, Sarah, Dr. Baker, your bikers definition and term as we might write this and draft this policy further. But we are reserving, out of respect and really anticipation and excitement for the biomass study that's happening in Marin County, being led by Belle, Bill Carney, others, the Marin Resource Conservation District. So in that policy statement are these nature-based solutions and ways in which the Marin Conservation League can support those, and a placeholder around biomass as we wait for that study to come out and learn more and want to be supporting that. Bob, that's about all I think you wanted me to share, or hopefully that's helpful.
All right.
And then please,
Thank you,
if there's other things, let me know.
Okay. Thanks so much, David. Okay, let's go back to the agenda, and the next item is related to the presentations and what David said, and it has to do with the Marin biomass project. Belle and Bill Carney have been leaders of that. Belle?
Belle, you're muted.
And we can't hear you.
I'm muted now.
Yes.
You're good.
That's great. Thank you. Well, we are here today, Bill and I are here today to tell you about the Marin biomass project. And Bill, if you want to put the start the slideshow, that'd be good.
Okay, if I have shared screen, there we go. Yes.
Okay.
And hold on one more second. If I can find, there we go. Is that display okay?
That's fine.
Great.
So as I say, we're here today to tell you about the Marin Biomass Project. And I am Belle Cole. I'm chair of the steering committee of the that oversees the project. And Bill Carney is on the steering committee. And I'll just mention there are a few other people here who are on the steering committee. One is Jeff Creque. Another one is Bruce Goins. I saw him here. And I don't know if any other members are here, but they may be. So I'm just going to start out with some simple thing that many of you have wonder about is what is biomass? And biomass is renewable organic materials that come from plants and animals. And you see the circles on the left of the slide. It includes woody biomass generated by woodland thinning and landscape trimmings to source separated and mixed organic streams generated by the collection of metropolitan wood debris, food scraps, yard materials, and agricultural biomass. And the project was developed in response to increasing flows of these materials, developed from wildfire prevention activities and by landfill diversion efforts in the county. Before I go on, I just wanted to say that the project that we're working on is a different scale and has a different purpose from what we've been listening to today, but any kind of assistance we can get from those with the expertise that are available is going to be useful to us. Next slide.
Okay.
Okay. No, the other one.
Sorry.
Yeah.
Okay.
Yeah. So how our solution works, and that's how the biomass project solution works. First of all, it's an endorsed solution of Marin can, formerly Drawdown Marin, and it is and it's a study. It's basically a study of marine biomass, ultimately to recommend economically viable and climate responsible pathways. It's also a local stakeholder collaborator to help implement study recommendations, and it supports local economic development, and it advances climate change reduction and resilience. Our solution makes the most sustainable use of biomass feedstocks being generated as part of wildfire prevention and landfill diversion activities in Marin County. Each of these items corresponds to a part of the biomass utilization study. Okay, so how did this start and where are we now? It began with a Marin can inspired group that proposed a biomass feasibility study and was endorsed by Marin can, formerly Drawdown Marin, in the summer of 2000. And then the group undertook the study, and the process, and a year later, 2021, was selected by the Office of Planning and Research as one of a pilot funded by a $500,000 grant. And in 2022, the Marin Resource Conservation District, as fiscal agent, signed a contract with the state, launching the Marin Biomass Project. And since then, MRCD has appointed the steering committee, that's us, to oversee the project. They've appointed a project manager, and they've selected a study consultant, Spatial Informatics Group. And the study began in November of 2022. And this is the study. It's a 7-part sequential undertaking. And part A is the biomass feedstock confirmation. And it estimates the amount of biomass handled in the county. And part B is the utilization pathways assessment. Part C, economic analysis. Part D, greenhouse gas analysis. And Bill Carney will be filling you in on some of the background of each one of these projects.
Okay. Yeah, the foundation of the biomass study is to clearly understand the quantities and also the quality of biomass generated from our green waste and also our wildlife prevention efforts here in Marin, both now and in the future. And that's the first part of the study. Once we understand the biomass being generated, we can figure out how to optimize the social and economic and environmental results of how we process these materials. We're now reviewing the first draft of this first chapter of our study, which we're glad to be able to show on this slide. The core of the study is the next part, which is the examination of potential utilization pathways to process these biomass flows. The top of this diagram shows some of Marin's basic biomass feedstocks, some of which can be treated on site. The vertical lines represent several possible pathways for converting biomass into useful products. And at the bottom are some of the primary outputs and potential value-added products for each pathway. And you'll note that 4 of these, 4 of them, actually lead to the generation of renewable electricity. So for example, the process of gasification, this line, could produce A, renewable hydrogen for potential fuel use, B, biochar that can sequester carbon and improve soil structure and moisture content, and C, the heat to generate electricity. So that's here. And right next to it, I wanted also to emphasize that compost is a major product of one of these pathways. And that's, of course, a primary resource needed for the Marin carbon farming that Jeff was talking about. And that actually is another of the Marin can key climate solutions needed to get below 0 greenhouse gas emissions. So the third part of the study looks at the economics of these potential processes and products of biomass utilization. That is, how much could be produced from available feedstocks, at what cost, and resulting in what market value. This will help assess the feasibility of each pathway and come up with a product strategy and a mix that's suitable for Marin. Some of these outputs are energy products. So you can see over here on the left, either fuels like renewable natural gas, or renewable hydrogen, or saleable energy like electricity. Conversion pathways can also produce different material products, as shown on the right, like mulch, fertilizer, compost, biochar, and wood products. The study's final core chapter is a greenhouse gas analysis that seeks to quantify both the greenhouse gas footprint of each pathway and its potential for carbon sequestration. So altogether, these 4 chapters, assessing feedstocks, utilization pathways, economics, and greenhouse gas, will form the basis of the study's recommendations of the pathways and practices that are best suited to Marin, and perhaps also for similar coastal counties in California. So back to Belle.
Yeah, okay. Where are we now in the process? Well, we just launched the Marin Biomass Collaborative. You see there, it says spring. And to help us review each draft chapter, participants in the collaborative will attend quarterly meetings to discuss and provide feedback on draft chapters of the biomass utilization study. This month, we're reviewing part A, the biomass utilization, the first chapter, and its assessment of the biomass flow from wildfire prevention, landfill diversion, and agricultural operations. And as you can see, quarter by quarter, completion of the study is scheduled for 2014. The project is organized formally as a project of the Marin Resource Conservation District. This diagram illustrates the structure. I'll explain the working from left to right. On the far left, the Governor's Office of Planning and Research is the funder who was given the $500,000 for the Marin Biomass project. And the Resource Conservation District is serving as the host organization and grant recipient. A project manager and a biomass study consultant, as I mentioned earlier, have been hired. And we have a steering committee who oversee all aspects of the project, which serves as a hub for a wider collaboration of public and private stakeholders interested in jumpstarting the development of additional affordable biomass utilization capacity. And the collaboration had its kickoff in January, and about over 30 people attended. As each draft study chapter comes out, the collaborative has the opportunity to review and provide feedback to the consultants. And the goal of the collaborative is also to create a forum for these participants to get to know each other and to develop shared language and objectives related to biomass recovery and utilization.
Belle, we're going to be running out of time pretty soon, and we do want to have time for Q&A.
Yes.
So
We're almost done.
Yep, got 2 more slides here, Bob. Okay, so yeah, returning to today's sequestration theme, we wanted to mention a few final parts of the biomass studies, greenhouse gas analysis. In addition to analyzing the emissions and sequestration potential of each utilization pathway, the study will also examine carbon sequestration losses and gains from wildfire activities and vegetation management and soil management practices. We will quantify the carbon sequestration resources and emissions of the biomass sector, and we'll recommend changes in the infrastructure management and processing that could yield greenhouse gas benefits. And just we wanted to end by emphasizing that the biomass project is part of the larger effort of addressing climate change. Reducing catastrophic wildfires, one of the state's most challenging climate problems, because fire produces huge amounts of carbon emissions. The 2020 fire season alone is said to have produced double the amount of overall emissions that had been reduced in California in the past 2 decades. So it's a big impact. And at the same time, by promoting healthy forests and agricultural lands, these sequester about 1/3 of Marin's overall greenhouse gas emissions. So that's a big contribution we hope to have a part of as well. Okay, and I think for that we'll then, and I just wanted to mention the alignment with the ecologically sound practices, which MCL and the ESP partnership have been involved with as well with MWPA. So with that, I think we will open up for any questions that folks might have.
Okay. Okay, are there questions about this? Okay, so David, what's the makeup of the collaborative? David Muller asks, what's the makeup of the collaborative? What sectors are represented?
Excuse me. Well, it's a broad set of stakeholders, and I can easily provide him with a list of the members. There are about 30 right now. We have people from forestry. We have people from waste processing. We have people from MCE. We have people from haulers. We have academicians. We have the first scholar in California to create what was called the California collaborative on biomass from Davis, who's part of it. So it's a broad mix, and I can provide whatever we can provide, the names of people. And if you have somebody you would like to think of bringing in, if you would like to be part of it, just let us know. It's brand new. We've had one meeting. We're going to have another one next week, and so it's very innovative. And any particular thought, David, you have it in mind about that?
No, it was just, I just was curious if it was like primarily the agricultural sector, or was it the, you know, as you mentioned, the haulers, or, you know, who was interested in this? And it sounds like it's a very broad representation. So that's great. No, I wasn't looking for specifics, just sort of a general feel for it.
Okay.
Thank you.
Yeah.
What I'd like to emphasize is that this is just one of 6 projects that got funded. It was a very competitive process, so this really stood out as something that was worthwhile for the Office of Policy Research to fund. I think what we need to do is move on, and so thank you, Bill and Belle. And the next segment is on recent EV infrastructure developments. And I see Carleen popped up on the screen, and there's Annika. Carleen, why don't you take it away?
Okay, hi everyone. So Carleen Cullen with Cool the Earth, and we run Ride and Drive Clean, a major collaboration to advance driving in the Bay Area. And my colleague Annika Osborne is here also. Excuse me. So there's been many changes in the EV infrastructure world. First of all, on Wednesday, the federal government at last released the guidelines for the regulations for the NEVI funding. So this is $5 billion for fast charging infrastructure along highways and corridors. The goal is to have about 350,000 of the fast charging stations across America. This was a formula, so each state received a certain amount of money. And so that's moving forward. There's the Justice 40 criteria with this and all the government spending, that 40% of the funding needs to benefit our low wealth and disadvantaged communities. In the regulations is a 97% uptime. Many of you are familiar that we did a study with UC Berkeley about a year ago showing that about a quarter of the stations funded by taxpayer dollars were not functional. The fast charging stations, these are not Tesla. That was really a game changer for the state and federal government to start putting in 97% criteria for the stations. Unfortunately, there's no verification, third-party verification of data, no field testing, and no consequences for non-compliance. We're working with the CEC at state level very deeply on how we define those things to make sure the stations actually are operational. So that's big news that happened. As part of this, Tesla is very interested in this securing some of the $5 billion. And the White House announced, and Elon Musk confirmed, that they will be opening up a certain number of their stations, which they have about 6,700 plugs right now in America. They're going to be opening up about half of those for both new and existing. They're planning on applying for this NEVI funding, the $5 billion. So that's very significant. They've been hinting about that for a long time, and this funding allocation has gotten them to move the needle, which is great. And then also the NEVI funding comes from the Infrastructure Investment and Jobs Act. And as part of that, there's another $2.5 billion, part of which is for community infrastructure. So about 6 months ago, Congressman Huffman asked me if I would create a team and lead our application to this RFP when it becomes available. This would be for Marin City, the Canal, Novato, and rural West Marin, as well as a few communities in the East Bay, disadvantaged communities. So we'd be looking at bringing some pretty major infrastructure to these communities if we're awarded the grant. And Congressman Huffman has said that he had personally hand walked through that hand walk the application through. So we're working with all the community-based organizations, the elected officials, sustainability officers. There's a whole team of us that are working to prepare for the grant application.
And
So-
Carleen, why don't you just explain what NEVI is?
Oh, sorry, the National EV Charging Infrastructure. So when Congress passed the Infrastructure Investment and Jobs Act, IIJA, there are two components. One is the NEVI for highways and corridors, and the other is for alternative highway corridors and community grants. So all in, it's $7.5 billion over 4 years now.
Okay. Go ahead.
Turn it over to Annika, trying to go fast and quick.
Yeah, I know we don't have a lot of time, so I'm going to just talk a little bit about incentives and bidirectional batteries. So most California residents currently qualify for up to $9,500 in incentives on a new EV with the state rebate and the federal tax credit, both which now have income and vehicle price caps. So the California rebate is for $2,000 for fully electric and $1,000 for plug-in hybrids. The federal clean vehicle credit for $7,500 is a credit against tax liability for vehicles with final assembly in the United States, like the Chevy Bolt, the Ford Mustang Mach-E and F-150 Lightning, the Volkswagen ID4, and Tesla Models 3 and Y. There are also several plug-in hybrids that also qualify for the tax credit. I'll drop a link to the qualifying EVs at the end of my presentation. We are following incentives very closely, so our messaging and presentations are up to date. Join us for a webinar to learn more. And then a little update on bidirectional batteries. So today there are several exciting EVs with bidirectional batteries. The Kia EV6 and the Hyundai Ioniq 5 offer vehicle to load capabilities and can power up large appliances like refrigerators for many days. And the Fisker Ocean coming out later this year, as well as many other vehicles will also have this capability. So we're moving quickly with bidirectional. The Ford F-150 Lightning offers a more robust vehicle to home solution. So it can be integrated into the home's electrical system to provide backup energy to your home. Really, it acts like a generator at home, and it's a battery on wheels when you need electricity away from home. We're following the vehicle to grid integration. Also, currently PG&E is working on pilots with Ford and GM, and Fermata Energy is also piloting V2G integration in New York with Nissan Leafs. We're currently developing a new webinar, EVs for backup power, which will be offered twice in late March. Join us to learn more. And we'll also be demoing bidirectional batteries at our upcoming local shows in Mill Valley and San Rafael. And I just have one quick last announcement. We're super excited to be bringing back the EV discount campaign this March, the first one in a few years. There will be discounts on 4 or 5 EVs with pricing below MSRP, which is huge in this market. This will include the very popular Volkswagen ID4 with a base price under $40,000, and also comes with 3 years of free public fast charging. It's a great opportunity. We'll be messaging. I know many of you are my partners. I'll be sending out a note with details soon. So I'll drop a couple of links in the chat now. Thank you.
Great. Terrific. So questions for Carleen or Annika? I don't have a question, but I do have a statement that vehicle to home, vehicle to grid is something that we, Marine Conservation League, Climate Action Working Group, Clean Energy Group are very interested in, because we see that as being foundational for having distributed energy resources, supplying power to the grid when needed. So anything you folks find out about it, be sure to pass that along, because we're very interested and think that that's something which has great promise, including pilot project for CCAs like MC Clean Energy. Pam, you have a question.
Thank you so much for the incredible work you do at Ride and Drive Clean. What are some of the current big obstacles for vehicle to home? I know it's different from vehicle to grid, but what are the ones vehicle to home that need to be overcome before we can start utilizing it?
Well, I think one of the things that we're waiting for is a lot of the OEMs have to kind of allow this technology. So currently Nissan allows it with its Nissan Leaf, and they have a special, they've been doing this in Japan for a while. They're starting to demo this here and pilot this in the United States. But I think a lot of the, home energy management providers like Decibel and Wallbox are really waiting for the approval from OEMs to be able to use this new technology.
Yeah, like Tesla in particular has said, you'll avoid your warranty if you use it for any sort of power backup. So, we think it's mostly because they want to sell power walls, but they talk about the cycles of the battery, et cetera. But so we're really waiting for these inverters. There are some workarounds to power your whole home, but those are generally not on the market or not widely on the market yet. And as Annika said, a lot of there's about, I think, 8 vehicles now, models that will allow for this, but a lot of other manufacturers have not come behind us yet, but they will.
So thank you so much, the pair of you. That was great. And I think what we're going to wind up doing is just going to announcements. And one that I want to raise is that next month we'll have a session on building electrification. Brian Reyes from the county will talk about efforts to change ordinances around building electrification, what's on tap for 2023, and we'll also have a speaker from the New Buildings Institute. And Peter, do you want to add something to that?
Yeah, so I was actually wanted to ask a question earlier about disadvantaged community, but I saw the answer was covered in the chat. But yeah, next month we're definitely looking to go after building electrification and not only cover some of the technological issues, but what are the market and policy barriers to getting electrification more widespread across California, and in particular in Marin and existing buildings.
Thank you. Are there other announcements? Oh, Wendy. I was shocked that there were no other announcements. Wendy and then Jody.
Yes, hi. We've been Wendy Callan, Sustainable Marin. We've been talking about getting launched with our Climate Rapid Response Network, and I'm happy to announce that we are now set up to let people sign up, and that we're going to be focusing on water conservation and reuse as our first project. You can go to sustainablemarin.org in order to sign up, and I'm going to be contacting organizations individually to ask them to get a message out to their people. We're basically looking for people who can show up at meetings and write letters of support for various policy initiatives.
Thank you, Wendy. Jody?
Yeah, by way of 350 Marin, I put a quick report in the chat box because I wasn't sure we'd have time, but we do have an event coming up along with Third Act nationally. So that's going to be at the San Rafael Plaza. We're going to gather at the bank there at the B of A and then walk over to the Citibank for an hour outdoor protest on cutting up credit cards and pulling money from corporate banks. So I just want to encourage everybody, if your banking at a major corporate bank, think about moving at least some of your money to a credit union or another bank, a local bank, so that we can stop funding the fossil fuel industry. Your money is going there. We're also working hard with our interns. We have a couple high school interns starting and a new regenerative agriculture campaign. We also have an exciting summer intern who's going to be coming from the University of Chicago. Very interested. She's from Larkspur, wanting to know what's going on in Marin. So I'd love to have her connect with a lot of you and talk so that she can learn more about, and again, apply some of this local grassroots information and activism to her studies at the University of Chicago. So thank you.
Thank you, Jody. Belle?
Yes, I just wanted to make a short announcement that the Ecologically Sound Practices Partnership will has a meeting on March 14th on the subject of biodiversity, and we will be getting the subject matter and the speakers out to you soon, but you'll be hearing about that. And also MWPA and ESP are sponsoring or hosting a field trip in Marin City, and that's going to be at the end of March. Thanks.
So it's 10:59. Where I see no other hands up. So big thank you to our speakers, and thank you folks for attending. And we'll hopefully see you